Hello. Today we're going to continue our talk about zeros, and we're going to hopefully connect the factors that we've been working so hard on and the zeros of an expression. These next few examples sort of depend on us understanding a structure rather than being able to factor independently. And so our objective is students will be able to use the structure of polynomials to identify factors. And as I'm looking at this first example, I see write 9 minus 16x to the fourth as a product of two factors. And so far, I've not ever really seen an exponent of 4. I've really only seen something like this, and so you do it on the side, but 9 minus 16x squared. And what that truly reminds me of is difference of squares. So as you look at this and think, wow, that really looks like difference of squares, this is what we mean by structure. What is the structure of difference of squares? Well, I have the first term squared minus the second term squared. And if I think about this, this would really be 3 squared, because 3 squared is 9, minus, well, what did I square to get 16? Well, that's 4, and x to the fourth came from x squared squared. And so if I double check my work, 3 squared is 9, minus 4 squared is 16, times x squared is x to the fourth. And remember, really what I'm doing is 3 times 3 minus 4x squared times 4x squared. It's a good habit of making sure that you expand. And so if I go back to the original question, how would I factor this as a product of two factors? I can use this difference of squares idea, get my structure down, and then I can write 3 in the first, the A spot, and then 4x squared in the second spot. Now an extension question or a connecting question that we really need to be able to do is be able to take what are the zeros of a function. So the expression that makes up the equation is identical. And what it means by zeros, we definitely want to make sure we're solid with our vocabulary, but this just means I'm going to replace the f of x or the y with 0, and I have 9 minus 16x to the fourth power. And then I can factor this, and the whole reason why we want to be able to factor is I know if I have a multiplication problem set equal to 0 that one of the factors or the other is equal to 0. So now I have 3 plus 4x squared, and I have 3 minus 4x squared. And so when I begin to solve this, I can now write 3 plus 4x squared equals 0, and 3 minus 4x squared equals 0. There's a variety of ways you can use quadratic formula. You can use just algebra, but you have to remember to make sure you have the plus minus when you take the square root of both sides. But in the end, your answer will be x equals the plus and minus of negative 3 square rooted over 2. These are imaginary, and therefore they will not show up on your graph. And this will be x equals plus or minus the square root of 3 over 2. Again, you can use quadratic formula. You can use completing the square. You can use straight up algebra as long as you remember the plus minus. Moving forward with this idea of structure. So we saw with difference of squares kind of gives us something that we're really familiar with. And then we look at the next equation, or really expression, because we're not solving. And I just look at this, and at the moment I'm really struggling. I'm not sure I know exactly how to do this. But I think to myself, what if the expression said x squared plus 4x minus 21. So I see that the last term is exactly the same, but the other two terms are not quite there. Well, that one is pretty easy. It's x plus 7, x minus 3. And it would be really wonderful if we were able to replicate this. Well, let's look at the structure itself. So parentheses x squared plus 4 parentheses minus 21. Is there anything that I can put into these parentheses that would make this expression? Well, 4 times what equals 8? Oh, that's 2x. And then 2x squared, well, that would be 4x squared. And so now we have the ability to sort of factor it like we just did. In that first spot, I just have to fill in what is exactly my x value. Well, in this situation, it is 2x, and in the other, 2x minus 3. Now, all these x's going back and forth become really difficult to keep track of. So what we do in math is we call this U substitution. And this is a little bit easier to follow. So I take my original and I say 4x squared plus 8x minus 21. And I determine the u. The u is really what I just put in here. So I think of the structure itself, and I basically say, well, I know how to do u squared plus 4u minus 21. If u equals 2x, then I'd actually have my original. So I know that this factors into u plus 7, u minus 3. And then if I make a substitution, I now have 2x plus 7 and 2x minus 3. And so U substitution is a really useful tool when we don't know something or it's a little more complicated than we're ready to handle. We can find one that we do know and use that as a structure to help us sort of continue our problem solving. Speaking of structures, we've actually seen a few structures already this year. And what they are the sum difference of perfect cubes. It's identifying exactly the way they look within it. And so as you're looking at this, it might be helpful to actually figure out the formula. So I'm going to go all the way back to reverse tabular method. And I'm going to see if a plus b is a factor of a cubed plus b cubed. And what I know, if I start in this corner, is that I multiplied a by a squared to get a cubed. And if I bring this down, that means it's a squared times b. To get the 0 a squared plus b term that's there, I'm going to need a negative a squared times b. What did I multiply a by to get a squared times b? Well, that must have been a negative a b. Bring this down, I get negative a b squared. Again, to get a 0 term, I must have had the positive or the opposite value. So a b squared. Well, I multiplied that by b squared. And b squared times b is b cubed, which is exactly what I wanted. And so now I know that a plus b times a squared minus ab plus b squared is my factored form of a cubed plus b. Likewise, if we try the same thought process with our reverse tabular method for the other difference of cubes, I'll have a minus b. A cubed is where I began, and we'll hopefully get the correct answer down here. And so now I go through what I multiply a by to get a cubed, a squared, minus b times a squared plus a squared b. So I must multiply by a positive ab, which gives me negative a b squared, which I need a positive a b squared. So I must multiply a by b squared. And b squared times b is b cubed, negative, just like I wanted. And so now I know the other result is a minus b is equal to a squared plus a b plus b squared. And I'd pause the video right now and make sure I had written down these two equations, because they're going to provide the structure we need when we see a difference of cubes or a difference or a sum of cubes. And I want to give you one example to work with. And so as I'm looking at this, I have a cubed plus 27. So I understand this is a sum of cubes. And so I know the formula is a plus b, a squared minus a b plus b squared. And then I just make some substitution. Well, a is equal to a. So that doesn't really give us any insight, but 27 cubed is 3 cubed. So that must mean that b is equal to 3, so a plus 3, a squared minus a b is equal to 3, so I substitute it in, and 3 squared. And so now I have a plus 3, a squared minus 3a plus 9. Final answer. The other one, that looks like difference of cubes. And so I write that formula down just to make sure I get lots of practice and memorize it. A squared minus ab, but it really should be plus. So that's really the difference. I can always tell which formula I'm doing because the minus matches the difference of cubes or the sum of cubes, and then the middle term is the opposite of whatever my lead binomial is. So that's one way I've begun to memorize it. A in this scenario is equal to x, so I'm going to make that substitution minus 64. Well, what cubed is equal to 64? 4 cubed is equal to 64, so I make the substitution 4 x squared plus x times 4 plus 4 squared. X minus 4 times, just simplifying this, x squared plus 4x plus 16. Final answer. And so rather than having to do the division where I'm using long division or I'm using reverse tabular method, a little review, if I can use this structure, it really goes much, much quicker because I'm just able to apply the formulas that I was provided. Make sure you go back, review the vocabulary that you might have seen, summarize the results of using structure to factor as opposed to having to come up with everything on your own. Thank you.